Hello, we are going to see about the problems based on the state table and state diagram. In the first problem, their state diagram is given. They are asking to determine the state table for the given state diagram, right? Okay. So before going into the state diagram, we have to identify what sort of circuit is this, whether it is a Murray circuit or mealy circuit. Okay, so we know what is a mealy circuit. In a mealy circuit, output is a function of state and input. And if you take a Murray circuit, output is a function of state only, not on inputs. Okay, so if you see here, the convention is followed is, so here S0, S1, S2, S3, S4 are the states. Before the slash we have B, that is the input. After the slash we have the output. Okay, so B is the input, 1 1 is the output. Similarly, A is the input, 1 1 is the output, right? So we can clearly see this is a mealy circuit because it is going from the state S1 to S2. When the input is A, the output is 1 1, right? So output is a function of both the state as well as the input, right? Okay, so this is your, before the slash we have the input, after the slash we have the output. So the given circuit is a mealy circuit. Okay, now the question is draw the state table or determine the state table. Okay, so I can scroll a bit, right? So I'm going to draw the what I can say, state table. In state table, we are taking the present state, which is PS, and the input is x of t. Input is x. Okay, what can be the present? What are the present state? State can be S0, S1, S2, S3, and S4. So 4 possibilities. So I think you can write it. Yes, S0, S1, S2, S3, and S4. These 4 possibilities are there. Okay. Similarly, for the input, what are the possibilities of the input before the slash? Okay, before the slash, what we have A, we have B. So input, that is your x, can be take 2 values. One can be A, another can be B. Okay. So here we have taken the present state. Here we have taken the inputs. Now from the diagram, the state diagram, we can fill the state table, right? So look at it, which state we are now? We are, the present state is S0, input is A, right? Which state again you are going? You are going to the same state S0. Okay, again what is the output, comma, output is 0 1, right? Now what is the present state S0? What is the input? B. When the present state is S0, input is B, we are going to which state? S1. What is the output? Output is 1 1. Okay, now try to fill this. We are in what state now? Present state. Present state is S1. When the input is A, what is the next state? S2. What is the output? 1 1. Okay, when the input, we are in the state S1, when the input is A, we go to the state S2, output is 1 1. Similarly, we are in which state now? S1. When the input is B, to which state we are going? S3. What is the output? 0 0. Okay, now try for S2. We are in what state now? S2. right? We are in what state? S2. When the input is any input, see this hyphen indicates input can be A or B, don't care, right? This hyphen indicates it can be A or B, right? So for both A or B, where we are going? We are going to the state S3. What is the output? 1 1. Okay, it fill for S3. We are in what state now? S3. When the input is A, we are going back to the same state S3. Output is 0 0. When we are in the state S3, when the input is B, see this is the input, right? When the input is B, we go to the state S4. Output is 0 1. Okay, now we are in what state? S4. When the input is A, we go to the state 0 1. Okay, we go to the state S4, output is 0 1, right? Same state we are going when the input is A, 0 1. Similarly, we are in the state S4. When the input is B, to which state we are going? We are going to the state S0 with the output 0 0. Okay, right. So this is your state table, and here you can indicate clearly this is your next state comma Z, because this S0, these are all your next states. This 0 1 1 1 0 0 0 1, these are all your outputs. Okay, this is your output, this is your X is your input, P of S is your present state, N of S is your next state. Okay, so this is how we can convert a state table, state diagram to a state table, right? Now we move to the next example. Determine the state diagram corresponding to the state table. Okay, if you observe this, it's very clear. They have given the table, they are asking the diagram. Okay, so again, what are the states we have here? Think about it. We have A, B, C, D, E. We have 5 states. What are the inputs? A, B, C are the inputs. What are the outputs? This 0, 1, these are the outputs. Okay, so I think I can draw it here. Right? Okay, so I mark as states as A, B, it's up to, anyway we can draw, right? D and E. We have 5 states, right? When the present state is A, input is small a, we go to the same state A with the output 0. Okay, so what I am doing here, when the input is A, output is 0. When the input is A, we go to the same state A with the output 0. Now we are in the present state A. We are in the present state A. When the input is B, when the input is B, to which state we are going? We are going to the B state. Okay, we are going to the B state. What is the output? Output is 1. So this is your output. Right? Now we are in what state now? We are in the state A. When the input is C, this is your X is your input, right? Input is C. We are go to the same state A with the output 0, right? So I can even write it here like another value C/0. Okay, so in the present state A, all the 3 possibilities have been filled. Now we go to the present state B. That is the present state B. When the input is A, we go to the same state B with the output 0. Okay, this is state comma output. You can see NS comma output. 0, 1, these are the outputs. A, B, C are the states. Okay, right? So when the present state is A, when the input is small a, we go to the same state B with output 0. Right? We can see it very clearly. When the input is A, we go to the same state. From B, again we are coming to B with output 0. Right? Now, when the input is B, we go to the state C with the output 1. right? From B we go to the output C, but what should be the input? B, output is 1. Okay, now what about this? We are in the state B. When the input is C, we go to the state A with the output 1. Okay, from the B we go to the state A. When the input is small c, output is 1. Right? Now try to fill this. We are in what state? C. What is the input? A. Again, which state we are going? To capital C. Output is 0. Small c, output is 0. Now we are in the state C. When the input is B, we go to the state D. So from the state C, we go to the state D when the input is B. Right? We are filling this, right? The input is B, output is 1. Now we are in what state? Same state C. When the input is C, we go to the state A. Right? So we go to the state A. When the input is C, output is 1. Okay. Now we are in what state? D state. When the input is A, we go to the same state D with the output 0. Okay. Now when the input is B, we go to the state E. From the D, we go to the state E. When the input is B, output is 1. Similarly, when the input is C, we go to the state A with the output 0. One minute. Yeah, here we made a mistake, right? This should be not coming here, right? Where it should be coming? We are in the state C. When the input is C, we go to the state A with the output 1, right? We are in the state C, so it should be coming here. From C, when the input is small c, we go to the state A, capital A, with the output 1, right? Okay. Now come to the last one. We are in the state D. When the input is C, we go to the state A with output 0. Correct. That is small c. Okay. Right. Now we are in what state? E. Last row. When the input is small a, we go to the same state E with output 0. So we are in E state, we go to the same E state. When the input is A, output is 0. When the input is B, we go to the A state with output 1. From the E state, we go to the A state. From the E state, we go to the A state. When the input is B, output is 1. Similarly, we go from the we are in the state E. When the input is C, we go to the same state A with output 1. So I can write it again as C/1. So this is the state diagram for the given state table. Right? Now this circuit is also a mealy circuit because output depends on both the state as well as the inputs. Okay, the given circuit is also a mealy circuit. Because output depends on both the input and states, right? Now we move to the third problem. What is asked is, determine the state diagram for the sequential circuit described by the following expressions. Okay, so what is given is S of t is the present state, t plus 1 is the next state. Okay, what are the possibilities of inputs? Inputs can be A, B and C. When the input is A, S plus t plus 1, which is the next state. Okay, remember t plus 1, that is time plus 1 is the next state. S of t is the present state. Okay, when the input is A, S of t plus 1 is equal to S of t. When the input is B, S of t, the value is added with 1. The present state value, whatever you have, is added with 1 and mod 5. Mod 5. Mod 5 gives the remainder. When I mod operation with 5 gives the remainder. For example, 4 mod 5 is 4, 5 mod 5. 5 mod 5 is 0. 6 mod 5 is 1, 7 mod 5 is 2. Okay, it gives a remainder when the input is B. Similarly, when the input is C, next state is equal to 2. Okay, and what about the output? Output Z of t is equal to 0 if the state is even, is equal to 1 otherwise. Even means otherwise means odd. Simple. Now they have in the last line, in the question they have given, there are how many states? There are 5 states. They are numbered as 0, 1, 2, 3, 4, 5. So totally how many states? 5 states. They are numbered as 0, 1, 2, 3, 4 and 5. Okay. Which they are asking, draw the state diagram for the given sequences. Right. So I am going to draw the state diagram. So what are the states? 0 is one state. Okay. You can make it like this. 0 is one state. 1, 2, 3, 4. Right? And you can clearly see output. Output depends only on the states. Am I right? Output Z of t is the output. This is your output. Output depends only on the states S of t, not on the inputs, not on x values. Right? So it is what machine? It's a Murray machine. Output depends only on the states, not on the inputs. Okay. So what I am going to do is, I am going to modify this. Right? Let me put it as 0. That is the state. 1, 2, 3, 4. Okay. So that is a 0 to 4 is the states. Remember, when the state is even, it is 0. What is even? That is, when the state is 0, it is 0 is an even number, output is 0, /0. Okay. So when the state is 2, which is an even number, it is 0. When the state is 4, which is an even number, it is 0. What are the other cases? Odd numbers. When the state is 1, it is 1. When the state is 3, it is 1. For odd numbers, it is 1. For even numbers, output is 0. Okay. So we have drawn the state and this relation is done. This part has been done. Okay. Now we are going to implement what is the relation between the next state and the present state based on the inputs. Okay. When the input is A, what is the meaning? S of t plus 1, that is the next state is same as the present state. Next state is same as the present state when the input is A. Right? So think about it. Okay, we are in the state 1, 0. When I give the input A, we go to the same state 0. Okay. Right? Similarly, we are in the state 1. When the input is 1, input is A, we go to the same state. We are in the state 2. When the input is A, we go to the same state. We are in the state 3. When the input is A, we go to the same state. We are in the state 4. When the input is A, we go to the same state. Based on this expression. Look at this condition. S of t plus 1 equal to x of t if input is A. X is equal to A. Right? This x is your input. Remember? X, can use some other color. X is input. Okay, right. Now, what is, when the input is B, what happens? Present state value plus 1 and I have to take mod operation. Okay, right. So we will make it, we are in the state 0, when the input is B. When the input is B, what happens? When the input is B, we are going to make ST plus 1. Present state is 0, so 0 plus 1, it is 1. Okay, it is 1, that is we go to the state B. We are going to the state 1, state 1, when the input is B, we go from 0 plus 1. See, the state is 0, we go to the state 1. We go to the state 1. Right? Okay. Now we are in what state? We are in one state, state 1. Right? when the input is B, we go to what state? State 1 plus 1 is 2. Mod 5. 2 mod 5 is 2. Okay, so we go to the, when the input is B, we go to the state 2. Similarly, in which state we are now? 2. S of t is 2. Input is B. So we go to the 2 plus 1, 3. 3 mod 5 is 3. From the state 2, we go to the state 3. And the input is B. Similarly, in what state now? We are in the state 4, 3. Right? When the input is B, so 3 plus 4, present state is 3. So 3 plus 4 is 3 plus 1. 3 plus 1 is 4. So 4 mod 5 is 4. Okay, so from 3 we go to the state, the input is B. Similarly, in what state we are now? We are in the present state is 4. So 4 plus 1, it is 5. 5 mod 5 is 0. 5 modulus 5. 5 mod 5. Remainder is 0. Okay, 5 mod 5 gives the remainder which is 0. Okay, when the input is B, we go to the state 0. From the state 4, we go to the state 0. We can see from the state 4, we go to the state 0. Okay, right. What about the last condition? When the input is C, we go to this, we go to 2. We go to 2, right? So we are in the state 0. When the input is C, we go to the state 2. We are in the state 1. When the input is C, we go to the state 2. Okay, we are in the state 2. When the input is C, we go to the state 2. We are in the state 3. We are in the state 3. When the input is C, we go to the state 2. Okay, we are in the state 4. When the input is C, you can see when the input is C, we go to the state 2. Similarly, we are written for everything. Okay, so this is the state diagram for the given function, right? First thing, you have to be very clear what is the state, what is the input, and you have to observe that how many states are there. Here they are clearly given 0, 1, 2, 3, 4, totally 5 states, and observe that output depends only on the state. So it is a Murray machine. In Murray machine, inside the circle itself, below the state, you can make it as an output. Okay, normally what we do is, if you make a circle, this is the state slash output. Okay, it's clearly given when the state is even, it is 0. So wherever we have a even state, 0, 2 and 4, output is 0. Right? For other state like 1 and 3, which is an odd number, for that it is 1 otherwise. Then based on the transition, that is the next state, t plus 1 is the next state, this is the present state. Based on the conditions, when the input is A, we follow this rule. Present state is, next state is equal to present state. When the input is B, next state is equal to present state plus 1 mod 5. Next, when the input is C, whatever may be the state, next state you have to go is, that is t plus 1, you have to go is 2. Okay, that is your, this is your next state. Right? S of t plus 1, that is the next state. Right? So based on that, we have filled this. So this is the state diagram for the given question. Okay, right? I hope this lecture was very useful to you. Have a happy learning. Thanks for listening.